Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
So, hello everyone. Am I properly audible and visible? Can anyone please confirm in the chat box so that we can start? Hello Logan. Hello John. Hello Yashwant. Can you please confirm in the chat box that I am properly audible and visible so that we can start without wasting any time? So, I will be sharing my screen as well. Kindly mention that it's properly visible to you all. Okay, Yashwant, thanks a lot. So that let's start then. Okay, so can you please mention in the chat box that you're present, and at the same time, can you please like this session as well on YouTube, and subscribe the Geeks for Geeks practice channel as well. I will be telling you why that's very important. Hello, Naman. So let us start then. Okay. So I would request everyone to call their friends who are interested in learning the traversal techniques of graph, namely the breadth first search and depth first search. Okay. So we will start very soon. Let's just wait for 1 or 2 minutes maybe. And before that, let me introduce myself. So my name is Gourav Kumar Shaw, and I'm presently in my third year. So yeah, I'm presently in my third year, and I'm a student at IIT Kharagpur studying Bachelor's of Technology. Okay, and I'm also a mentor at Geeks for Geeks. That is the reason I'm taking this session today. Okay, so this is a session two, and we will be having 13 or 14 more sessions throughout the month of December. And I will be covering all the important topics in graphs algorithms. Okay, so basically, this session is called Graph Tree session. Hmm. This session is called Graph and Tree session, and I will be covering all the important concepts and ideas required for graph and trees. And also, yeah, one more thing is that um, yeah, I will be covering all the important concepts needed from interview point of view. So basically, I will be teaching the theories, and I will also be discussing important problems. And at the same time, I will also be giving you all homeworks as well. Okay. So basically, homework will start from the next session. Okay. How many of you all attended my previous, that is yesterday's session? Can you do a plus one in the uh, audio video is desyncing? Okay. There is some lag here. Let me check why exactly is that so. Yeah, okay. Let us continue then. I hope everyone is able to see myself as I am. Okay. Basically, yeah. The link to the slides are already given in the description. You can find it. So basically, I will be writing the slides and you can refer it to it later. Okay. And I would also request everyone to check the description of the this YouTube stream. On that, you will find the link to self-paced course on GFG. And Geeks for Geeks self-paced course is one of the very best self-paced course out there for learning data structures and algorithm. And I would recommend everyone to buy that course for your upcoming internship and placement preparations. Okay, let us begin with the study today. Yeah. Yesterday on the previous session, we studied about graphs in general, the terminologies of various graphs and trees, and at the same time, we learned about directed and undirected graph. We learned about the way about nodes and about edges and what it means to how to represent graph. Namely, there are two ways to represent graph. One was through the matrix method, and the other was through the adjacency list method. Okay, and we saw the coding part as well of how to represent both of them. So now today we'll be studying the most important and the related to graph is how to traverse a graph. Okay, how to traverse a graph. Okay, basically, okay, I'm sure there would be no echo. Sorry for that. Hmm. So let's start. Can anyone tell me the two very famous graph traversal algorithm that exists? Okay, yes, it's a DFS and it's BFS. Okay, basically, DFS is called depth first search, and BFS is called breadth first search. Okay, these are two traversal algorithm. Now, yesterday in the session, I told you about what exactly are graph. So, graph is basically a data structure, which is not a linear data structure. Instead, it is a hierarchical data structure. Okay, so we can represent data in the form of nodes and edges. So, basically, every graph will contain a node and it will contain an edge that will connect two different nodes. Okay, so let's say if there are two nodes and there is an edge between the two nodes, the edge is used for connecting them. And each of the node will contain a value. Let's say this node contain value 2 and this node contain value 1. So we are storing the values in every nodes and representing in the form of nodes and edges and in a data structure of called graph. So, but since it is a data structure that contains data, we need to access those data. And with the help of these two algorithms, it is made possible to traverse these two graphs and access the data present in the graph. So there are namely two algorithms which are most famous and both are important on its own kind. Okay, the first is the depth first search and the second is the breadth first search. So depth first search is a recursive algorithm and breadth first search is an iterative algorithm. Okay, so I hope this is clear to everyone. Yeah. So we have 9 people with me right now. So I would want all of you to kindly interact with me while the session progresses. And if you have any doubts, kindly mention in the chat box. So first, what do you want me to teach? Depth first search or breadth first search? Okay, let's see. Anyone? Hello, Yashwant. Okay, so let us start with depth first search. So as I previously said is that depth first search is a recursive algorithm. So therefore what it uses the idea of recursion. Okay, so let us look into how it has been applied. Okay, so let us see that. Let us consider a graph. Hmm. So first I will be considering a very simple graph. Let's say I have got 1 and this goes to 2 and then this is 3 and then this is 4 and this is 5. Okay, so let's say 5 is connected to 1, something like this. Okay, so now basically yeah, so basically we are asked that we will start DFS from node number 2 and we want to print the way the graph is getting traversed. Okay, so can anyone tell me what exactly will be the output and how we are going to proceed? Hmm. Okay, so let's say we are starting from node number 2. So, if someone is asking to do a DFS starting from node number 2, the output would look something like this. It will be 2 first, then it will be 4, then it will be 1, then it will be 3, and then it will be 5. No, the question is how am I obtaining this output is exactly how the algorithm works. Okay, so now I will teach you how it will work. So basically the word depth means that at any given node, what exactly it is going to do is go to the depth of that node. So basically, it will keep on exploring the depth of the node as much as it can be explored. For example, if my algorithm is at node number 2, it will try to go to the depth of 2. On this side, it is seeing that it has only one node, node number 4, and further it do not have any depth. So it will go till node number 4 and stop, or then it will backtrack. But when it will come till 1, it will see that from 1 it can again go to 5 and it can again go to 3. So it will keep on exploring the depth as long as the depth can be explored. So it will stop at 5 from this side, it will stop at 3 from this side, it will stop at 4 from this side. Okay, so that is the idea of recursion. Because when we are using the concept of recursion, it means that we are recursively calling any function. So whenever we are, and the recursive function keeps on calling itself until and unless it can no longer call. So basically until and unless it is hitting a base condition. And the base condition here it is that it no longer has any nodes that it can explore. So that is the point the recursive function will stop. So this is the idea of depth first search. I hope everyone understood it. Okay, So let us know few important points here is that it starts traversal from any given node. So it will start traversal from any given node and it will try to explore the farthest node possible. The important point here, it will try to explore the farthest node that is possible from that point. Okay. Okay, so it will try to explore the farthest node that is possible from that point of time. Okay, now after it reaches the farthest node and it sees that no other node is possible, it will backtrack from there onward and it will try to go into some other region where a node can be explored. So if it is able to find a new path, it will just try to explore. And meanwhile, it will also keep a path. Okay, so basically, let's say it first went to 2, then it goes to the next node of 2, 4, but it cannot find anything else, so it will print 4. Now it will again go to 2, it will again go to 1, it sees it will explore 1, it finds 1 and it prints 1. Again it goes to the depth of 1, it goes to 3, but again it is not able to find any depth, so it will return to 1. So 1 will again go to the next step, that is 5, it will print 5. So this is how all the nodes were explored and depth first search is complete. Excuse me. So this is how it will work. Okay, so let us look into the, yeah, so how exactly are we going to implement this concept in the form of a code? Does anyone have any idea? Kindly excuse me. Yeah, so basically what will happen here is that so there, let me write a pseudocode approach for how to solve a depth first search. Hmm, yeah, so I am writing a pseudocode. The first step is we have to start. You have to start from any node. It can be any node. It can be any given random node, or it can be the node number 1 as per the question. Start from any node. Okay. So after the first step is done, the second step is make an array to keep a track of visited node. Once visited, make that node visited. Okay. So we will be keeping an array. So basically, this array will be called the visited array. So this visited array will keep a track of all the nodes we are visiting. For example, in the previous slide, we saw that we were starting from node number 2. So what it will do, it will just mark the node number 2 as visited. So this visited array will make sure that we are not revisiting any node that is already been visited. For example, if we are doing recursion, so let's say if I am not keeping this visited array, what it will do, it will go into infinite recursion. It will keep on calling the function again and again. But we don't want that. We want to stop. We want to check that whether this node has been visited or not. If it has been already been visited, it doesn't make any sense to visit that again. So how we will know that? We will keep that track using a visited array. For example, let's say the node number 1 is visited. So we will mark this node number 1 as 1, and the remaining nodes will be 0 because those are not visited. If at any time we are visiting any node, we'll just mark that visited of node is equal to 1. Okay, got it? Hello Yashwant, hello Naman, hello Vivek. Are you all listening to me? Yeah. So I want you all to interact with me via the chat box, and we can make this session interactive. The session is won't be very long. It will be just around an hour or so, and we'll be learning very interesting stuffs here. Okay. So this is the second step. The third step involves here is that we will print the current node. Okay, why will print? Because we have to do something, because we are learning the traversal technique and we have to print the node. So let's print the node. So we will be printing the current node. Okay, so initially we were standing on node number 1. We marked that node number 1 is visited and we printed the current node. Now what we will do, we will recursively call the function, but with this time we will send all the adjacent nodes that are present to node number 1. For example, node number 1 has 3 adjacent nodes. So it will keep on recursively calling for each of the nodes. Okay. Hmm. So basically, let's say 1 is connected to 2. So it will recursively call for node number 2 if node number 2 is not visited. Okay. So once it calls for node number 2, it will again call for all the children of node number 2 if those are not visited. That is how we will proceed in depth first search. And once we are reaching any node which doesn't have any child, and there are no any way to explore other depth, so what it will do, it will backtrack and then it will try to find any other nodes which are not yet visited. So that is the beauty of depth first search. And by this recursive methodology, we can basically traverse all possible nodes. Uh, okay, and we can also print it. Okay, so this is how it will work. So now what will I do? I will just try to show you a code and do a dry run as well. Okay, just give me a minute. Okay, so what you all can do here is that you can just open Geeks for Geeks practice portal and just go to the DFS part. Okay, so let me share the tab. Can everyone see the tab? Yeah. So this is the practice problem of implementing depth first search on Geeks for Geeks portal. So now I'm going to explain you all the lines of the code. Okay. Okay, so this is the function in which it was implementing the depth first search algorithm. The first thing that we have to do is create a visited array. And initially, what we have done, we have put 0 in all of the positions. 0 implies that none of the nodes are visited. Now, let's say int start is equal to 0. So basically, we are free to choose at whatever starting node we want. But in this problem, it is already mentioned that use a recursive approach to find the DFS traversal of the graph starting from the 0th vertex. So it is already mentioned that our initial vertex will be 0. And one more important thing to note here is that our given graph, the way it is represented, the nodes are represented in the 0th index fashion. It is 0 based indexing. That is, the starting node is node number 0 and then node number 1. Okay. So our starting node will be int start equal to 0 because we are starting from node number 0. So what we will do, and also we have to store the answer as well. So this is a data structure vector in which called ls. It will basically store the answer. Okay. So now I will call this function. So I created a function called DFS. So this DFS is accepting a few parameters. The first parameter is the int node. Okay. Everyone getting it? What I'm trying to say? Hello. Yeah. So yesterday there were a lot of people on this streaming. And I guess around 20 to 30 people were there, and right now I can see only 10 people. So yeah, I would request everyone to kindly invite their friends also to join the session. Okay. And trust me, after 1 month, you all can basically get accustomed to all the algorithms of graph. Okay. So what exactly is this void DFS function trying to do? So this DFS function is basically accepting the first parameter, that is the node. So what exactly is node? So node is the node number in which the DFS function is going to explode. The second parameter it is accepting is the adjacency list. So I explained there are two methods to represent graph. The first one was adjacency matrix, and the second was adjacency list. So adjacency list was a better because it is a highly space optimized version of representing graph. So the second parameter it is accepting is of adjacency list. Okay. Now the third parameter that it is accepting is the visited vector also, because we have created this vector just to keep track of all the nodes that we are visiting. So basically it's so this vector will keep a track of all the vector we are visiting. Now after that we will also passing the ls function as well, because this vector is basically storing our answer. I hope it's done. So now, as I have mentioned in my slide, what was the first step? The first step of DFS traversal is that we have to mark that node as visited, because we do not want to repeat the visitation process. So basically what we will do, we will mark this node as visited. So visited of node equal to 1. This is the first step. After we are making that node visited, we will store that in our answer vector ls. Okay, because we have to print that. Okay, because if the node is getting visited, it means that our algorithm is only visiting it, and the question is asking me to print the order in which the algorithm is visiting each of the nodes. Okay, so the first node has already been visited. Now what will I do? I will basically go across all of the adjacent nodes of my given node. So basically this function for auto IT adjacent of node. So you remember in the adjacency list representation, adjacency of node, ADG of node is nothing but a vector. Okay, so this is representing a vector. That this vector contains all the node number which are adjacent to the given node, which is represented by node, variable node. So let's say if I'm passing node number 0 to this function initially, this will basically return all the vector, a vector that contains all the nodes connected to node number 0. So as you can see in this diagram, so 0 is connected to node number 2, 3 and 1. So initially this vector will contain the nodes 2, then 3 and then 1, the order in which it is stored. So this for loop will basically traverse each of these node one by one. So first it will traverse 2. Okay. So then it will check if that neighbor is visited or not. I have already told you that it makes no sense to visit a neighbor which has already been visited. That is the reason we were taking a visited node. So it will check whether it has been visited or not. If it has not been visited, then I will recursively call for the function passing this new neighbor. So let's say initially we started from 0, and then it will recursively call for the function 2. So now again this function will call for node number 2. The node number 2 will get marked as visited. Now this function will again call for node number 4. Now this node number 4 will also get visited. Now finally, what will happen when we are reaching on node number 4? As you can see that this for loop will not be executed because node number 4 do not have any unvisited neighbors. Node number 4 does have a neighbor called 2, but you know the 2 has already been visited because once we visited 2, we marked the 2 as visited. So this for loop will not, this recursive part will not get executed after we have reached 4. So what it will do, it will just backtrack out. Okay. So it will 4 will backtrack to 2, 2 will backtrack to 0. Now again, since 0 will try to explore other further possibilities that exist. So after 0, we have got 3. Okay, so as you can see, 0 will get printed, then 2 will get printed, then 4 will get printed. Now after 4, we do not have any further exploration to be done, so we'll return back to 0. So now 0 will explore its new neighbor, that is 3. So once it reaches 3, it sees that 3 doesn't have any unvisited neighbor. Okay, so it will again backtrack to 0. So now again it will go to 1. It sees that again 1 similar to 3 doesn't have any unvisited neighbor. So it will just backtrack again. So basically, as you can see, our output will be 0, 2, 4, 3, 1. Okay. I hope everyone understood it. Okay. Hello, Vivek. Hello, Devesh. So did you all understood it? Hmm. So any doubts in the algorithm? So this is the explanation of what I just did, how the DFS algorithm is working. And DFS algorithm is a recursive algorithm, and it is oftentimes the advantage of DFS algorithm is that, as you can see, only just 5 or 6 lines of code are there, and we are successfully being able to implement the concept of traversing the entire graph. And what happens in BFS algorithm is that you have to line a lot more lines of code because it is iterative algorithm. So that is the advantage of DFS, that very few small lines of code can work to basically traverse the entire graph. Hello, Shankar. Hello, Devesh. Yeah. So I hope everyone understood the DFS algorithm. So let us submit this code and see if there are any any errors. Yeah, no. So basically, the vector ls stored my traversal, the way we traverse the graph, and we have finally returned it. Okay. Yeah. So let us move to the next part. So before we move to the next part, let us look into other examples if they are present. Yeah. So now we have to discuss the time and space complexity. So what will be the time and space complexity? Can anyone tell me? Can anyone tell me what will be the time and space complexity of DFS algorithm? Yeah. So basically, hmm. First let's talk about the space complexity. Okay. So what are the spaces we are using? So first of all, basically we are using a visited array. So that visited array will be of size n, because if there are n nodes, we need to keep a visited array of size n. So first we are getting O of n because of got it? Yeah. So second most important space that we are using is that of at the adjacency list. Okay. So because adjacency list is basically storing my all the nodes and edges, but we usually do not consider adjacency list because that is the input. But anyway, let us consider adjacency list also. So this is the space complexity for storing the graph. This is space complexity for visited array. This space complexity for storing the graph. The third important thing was the auxiliary space, that recursive stack space. So let's say since we were using the idea of recursion, we have to basically implement the recursion using a stack space. Okay, because recursive algorithm always take a stack space. Okay, and in the worst case, the stack can have a size of n. For example, let's say if our graph is something like this, we have got 1, then 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to so on, a long straight graph till nth node. So what will happen? So let's say we are starting from node number 1. So node number 1 will recursively call for node number 2, and meanwhile node number 1 will be stored in the recursion stack space. So 2 will call for 3, and meanwhile 2 will be stored in the recursion stack. So similarly 2 will call for 3, 3 will call for 4, and all the nodes will keep on getting stacked one by one in the recursion stack space until and unless we are reaching the last node n. After n will be reached, it is seeing that it doesn't have any nodes in which it can visit, so it will keep popping after every nodes. So at worst case, we can have a recursion stack space of O of n. So as you can see, this is somewhat equivalent to saying that the space complexity is big O of n, linear space complexity. I hope everyone understood it. Yeah. So can I have a +1 in the chat of those who have understood the space complexity of DFS algorithm? So we will be now looking forward to the learning the time complexity. Okay. Can anyone mention the time complexity? Okay, yeah. Shankar is saying that the time complexity is V plus E. So let us see. Yeah. So basically what is happening is that we are traversing through all of the nodes. Okay, so DFS is also a traversal algorithm only. So we are traversing through all of the nodes and there are n nodes. Okay. So if there are n nodes, so what will happen here is that n nodes, so where n is the time taken for visiting n nodes and e is the traveling through adjacent nodes. So there are n nodes and e edges. So overall, the time complexity will be V of n plus e because we are traversing through n nodes and also we are traversing through the e edges as well. Okay. So the overall time complexity will be O of n plus e or V plus e, whatever the way it is said. Okay. So the time complexity is also linear. Okay. And the space complexity is also linear. So we are done with depth first search algorithm. Now we will be looking into breadth first search. So are you all ready to learn breadth first search algorithm? Yeah. So meanwhile, I would like to mention a few things. Is that okay? Vivek doesn't know. I hope Vivek that you understood the time complexity. Yeah. So basically, mhm, you can subscribe to the channel. Everyone, I would request everyone to like the streaming and subscribe as well. And I will be coming live every alternate day. And this is session number 2, and we will basically having a total of 15 or 16 sessions. Okay, and the 15 or 16 sessions will basically covering all the important topics related to graphs, its algorithms, and which are required for interview preparations. Okay, so that is how we'll proceed. Hmm. Okay, so yeah. Now, yeah, one more thing is that in the description you will find the link for Geeks for Geeks self-paced course. And let me tell you that self-paced course is one of the extremely good courses that you can find on available on the internet for learning data structure and algorithm. It has been taught very nicely, and I have personally used that course for my preparation for my interviews as well. Okay, so let us proceed to the BFS algorithm. Okay, so now does anyone know BFS algorithm? So BFS algorithm is basically breadth first search. Now the important part of this algorithm is that this is an iterative algorithm. Okay, so what does iterative algorithm means? It means that yeah, so we will not be using recursion, and we have to somehow use a loop because we are not using recursion, and we have to implement the idea of recursion using some other data structure. Okay, so how to do that? Okay, so let us draw a graph first. Okay, so I will draw a graph and then I will try to make you understand how the code works. Then we will dry run it. Okay. Give me a minute. Yeah. So yeah, let's draw a graph. Yeah. So let us say I have got a graph, node 1. This node contains three nodes, node 2, 3, 4. Then 2 in turn contains two nodes, 3 contains two nodes, 4 contains three nodes. So 2 contains 5 and 6, then 7 and 8, and then 9, then 10, and then 11. So the breadth first search algorithm will return what will it return? The order in which the traversal is getting done. So let's say we are starting from node number 1. So initially it will print node number 1 because you are starting from node number 1. Then it will print 2, 3, and 4. Okay. Then it will print 5, 6, 7, 8, 9, 10, 11. So this is the order. Okay, something like this. So what are you all observing? We can make a very important observation here is that BFS algorithm traverses in level order fashion. Okay, so it will try to traverse all the nodes in any given level. Then it will again try to traverse the nodes in the next level. So let's say if this was level number 0, so and this was level number 1, so and this was level number 2. Hmm. Okay, so initially it traversed all the node in level number 0, which was 1. Then it traversed all the node in level number 2, 1, it was 2, 3, 4. Then it traversed all the nodes in level number 2, 5, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it is basically traversing all the nodes in level order fashion. Okay, so this was also a graph. So let's say the graph is something like this. I have a node here, so it is connected to another node here. It is connected to another node here. It is connected to another node here. This is connected to this. This is connected to another node here, another node here, and another node here, another node here, and finally this is connected to this node and another node, and this is connected to this node. Okay, so basically, as you can see, this is a graph. Okay, so let's say we're starting from node number 1. So let me name it as node number 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I just named it randomly. Okay, yeah. So basically what happens here is that let's say we started from node number 1. Okay, so with respect to node number 1, how many nodes are there? So node number 1, since we are starting, so at level 0 we have node number 1, and finally we will also print node number 1. Okay, okay. Now with respect to node 1, we have to find all the nodes which are at a level greater than node number 1. So if level node number 1 is at level 0, we have to find all the nodes which are at level 1. And level 1 we can find just the nodes which are lying at a distance of 1 unit. For example, this node number 2 is lying at 1 unit, node number 3 is lying at 1 unit, node number 5 is lying at 1 unit, and 4 is lying at 1 unit. So what it will print the next node level, that is equal to 2, 3, 4, and 5. So after it does 2, 3, 4, and 5, it will start exploring all the levels which are at greater than level number 1, that is level number 2. So 2 means at a distance of 2 units from node number 1. So node number 1, 2 units are there, basically 6, then basically 10, then basically 9. Yeah, I think I'm done. This is 1, this is 1, and this is 1. Okay, so 6, 10, and 9 is done. After that, we have got 6. So 6 will, now level number 2 is done. Now we have to find level number 3. Now as you can see, level number 3 will be, from this side we do not have any level 3. From no level 3, no level 3. But from this side, we can see that node number 8 is at level number 3. Node number 7 is also at level number 3. And one more thing is there that you can see that once it will travel from node number 5, node number 4, it will also try to make node number 1 as level number 3. But node number 1 has already been visited. So we will not explore that part. So finally, at level number 3, we have 8 and 7. I hope everyone got it, how the concept of level is working. In case if you have any doubts, you can just type in the chat box. Yeah. So let us look into it again. So basically, let me just recapitulate again. So we will start from any given node, let's say node number 1. We will explore that node. Now after that, we will explore all of the nodes which are at a level 1 greater than the present level. So basically, since we are starting at node 1, its level will be 0. And after that, all the nodes which are at level 1 or at a distance of 1 unit from node number 1, we will explore those nodes only. So from 1 unit, we will see 2, 3, 4, and 5 are there. So we will explore these nodes now, and at the same time we'll print them. Now once we will explore 2, we will basically look into all the nodes which are at a distance 1 from 2 units. So we find that from 2 units we do not have anything, but from 3 node number 3 we have 9 and 10. So we took print that and put it in our data structure. Okay, so how exactly can we implement this concept in the form of a code? Can anyone tell me what data structure we will use to solve this problem? because we cannot use recursion. Okay, can anyone tell me? Let me give you three options and tell me how we are going to use. The first is stack, the second is a queue, the third is a DQ. Which option is correct? Which data structure will help us implement this idea? Yashwant is saying stack. Any more ideas? Q. Shankar is saying Q. Uh, excuse me. Yeah. Yeah. So basically, Shankar is correct here. So we will be using the idea of Q. And why we will be using the idea of Q? Let's see. So Q is something a data structure of first in first out type. Okay. So basically, whatever nodes that will enter Q, it will come out early. So basically, initially we will put the starting node that is 1. And after that, we will take out 1, explore all its neighbors, and we will put all the neighbors in it. Let's say 2, 3, 4. Now after that, since 2 went early, then 2 will be explored and all its nodes will be put up. Okay. Then 5, 6, 7 will be put up. Now the thing is that since we are doing a level order traversal, I want to print 2, then 3. So let's say, so since why am I printing 3? Because 3 went early, because 3 was explored previous to 5 and 6. So that is the reason I have to put 3 first. So that is the why reason we will be using a queue. But let's say if you have used stack, then this order would not have been maintained. So that is the reason we will be using the queue data structure. So how this queue data structure will work? Let us look into it. Let me show you the code. Okay, and then we will be seeing it. Okay. Excuse me. Yeah. So let us look into the practice session. Hmm. And yeah, so let me just explain it once using the graph that I have drawn it previously. Okay, so this is my queue. Okay, so initially we are standing at node number 1, so we will push node number 1 in the queue. Now after that, what we'll do, we will take out node number 1 from the queue, print it. Okay, and now the whatever node we have printed, we will consider all its neighbors. So the neighbor of nodes are 2, 3, 4 and 5. So we will just put 2, then we will put 3, then we will put 4, then we will put 5. Okay, now it no longer has any neighbors. Now at the same time, since we are putting it in our queue, we will also use a visited array to mark them visited, so that we are not revisiting or not re-putting them in the queue again, because our breaking condition from the loop will be whenever our queue is empty. And if let's say we are not putting a visited check, our queue will never be empty, and that is the reason we will get an infinite loop. So we don't want that. So that is the reason we will be using a visited array to keep a track of all the nodes we are visiting. Okay, I hope everyone understood it. So now what we will do, yeah. So this is done. So after that, what we will do, let's say we will take the first node that entered into our queue, that was equal to 2. So now we will remove 2 from our queue. Okay, because 2 is getting done. So 2, it will try to explore all its neighbors. So 2 doesn't have any neighbors. Okay, it had a neighbor 1, but that neighbor is already being visited. So there was no point revisiting or re-putting it into the queue. So 2 is also gone. Next, it will look at 3. So it sees 3 as 2 neighbors which are not visited, 9 and 10. So it will put 9 and 10 in queue. Okay. And it will remove 3 from the queue and it will print also. So I also have to print 2 also and 3 also. So it printed 3 also. So now it will consider 4. Okay. Before it takes 4, it will print 4 and it will go across all its neighbor. So now again we see that 4 doesn't have any neighbor which are not visited. So it will just remove 4 and not put anything. Okay. Now we are left with 5. So it will come at 5 and it will see the neighbors which are not visited are 6. So it will put 6 in the queue and it will print 5. 5 is done. So now 5 is also removed from the queue. After 5 is removed from the queue, it will go to the next element, that is 9. Okay, so 9, it will try to see the unvisited neighbors and it is saying that there is only one, that is 8. So it will put 8 into the queue and print 9. Okay, so now 9 is also done, 5 is also done. So after that, the number which is left is 10. So basically it will come at 10 and it will try to see whether it have any neighbor or not. It sees that there are no neighbors. So it will just print 10 and just remove from the queue. Then again we will see 6. Is there any neighbors to 6? No. So it will again print 6 and then it will just remove it from the queue. and finally it comes to 8, and it sees that 8 also doesn't have any neighbor which are not printed. Just a minute. 6 had a neighbor called 7. Okay, so once we had 6 had a neighbor called just a minute. Yeah, the 7 will also be there somewhere. So whenever we are exploring 6, 9 filled 8. 5 filled 2, 3, 4, 5. Okay, now it explored 3, it filled 9 and 10. Okay, done. Mhm. Then in 9 filled 8, and 5 filled 6. Yeah, so 6 will basically fill 7 also. Okay, so it will traverse 7 also, and this is how it will done. Okay, so this is how the BFS algorithm is getting implemented. Okay, so I hope everyone understood it. Yeah, so now let's look at the code part. Okay, yeah, and one more thing is that since we are emptying our loop one by one, the first in first out version of how it was going operating. So the moment the queue gets empty, it will break from the loop, because once the queue is empty, it indicates that we have traversed all of the nodes. Okay, so let's look into the implementation of the code. So this is the code of the BFS algorithm. Okay, I hope everyone is able to see the GFG screen. Okay, yeah. So let us look into it. Yeah. The first thing is that we have to maintain a visited array. So this is my visited array. Okay. So initially we have marked all the nodes as 0. Okay. Now after that, what we will do, since we are starting from node number 0, we will mark the node number 0 as visited. Okay. So that is the reason we are putting visited of 0 equal to 1. After that, we have a queue. Okay. So int queue, we are declaring a queue data structure, and we are initially pushing the starting node that was 0. So we are pushing the 0th node, and we are also maintaining a vector called BFS, which will basically store the answer. Okay, so now what we will do, we will do run a while loop as long as the queue is not empty. So initially we will take a variable called node, and this is basically the node under consideration. Okay, so let me just type it out here for you all. Yeah, so this is the node under consideration. So now what we'll do, I will just pop that node from there. Okay. After I pop that node, what will I do? I will do a bfs.pushback into that node, because I have to print that node. So that is the reason I'm storing it in my answer vector. So now I've removed that node, because it makes sense, because I've already stored the value of the node in a variable called node. So now I will traverse all of the neighbors of this node by this for auto IT adjacency of node. So my graph is stored in the form of an adjacency list. So basically adjacency of node will basically give a return a vector which contains all the node number which are neighbor to the vector, neighbor to the given node. Now, before I mark that visited, I have to check whether that particular node is visited or not. I will only visit that node if it is not visited. So if that node is not visited, then what will I do? As usual, I will mark that node as visited. Okay. And after I mark that node as visited, I will push that into the queue, because I am doing a level order kind of traversal, and I have to push it into the queue so that it can be explored after some time. Okay. After the time comes. So finally, when as you can see that when all the nodes will keep on getting visited, so this condition won't be getting implemented at the later stages, and finally we will be having our queue as empty. At one point of time, we will only be removing elements from the queue and not adding it. So at after some time, when all the nodes is visited, our queue will reach a point when it will become empty. So at that is the breaking condition from the loop, and finally we will return BFS. So let us look into an example. So did you all understood it? Can you have a +1 in the chat, those who have understood the concept of BFS as well as DFS properly? Excuse me. Shankar, hello Yashwant, hello Vivek. Yeah. So let us see this. Let's submit this code and see whether there are any errors or not. Okay, thank you, Shankar. Thank you, Yashwant. Yeah. So, so let us look into the example part of it. So, as you can see in the input, this was given. So, let us look into a bigger input. Uh, Not there. So, let's keep that away. So, initially we are starting from node number 0. So, in the queue, the node 0 will be there. Then 1, 2, and 3 will come. So, finally 4. So, basically the output will be 0, 1, 2, 3, and 4. So this is how it proceeded. So let us discuss the space and time complexity of our algorithm. So how exactly our algorithm is there? So can anyone tell me the space and time complexity? It is different from BFS or DFS. Any idea? Any idea? Okay. So basically the time complexity. Let's first discuss the space complexity. So can anyone tell me what are the spaces that we have considered in this? Okay, so let's take a new page. Yeah. So the first space that we have considered is the visited array. Okay, so that will account for O of n. After we have taken the visited array, we are taking a queue of size ns also. Okay, so that will also take O of n space. Okay, and also since we are representing the graph in O of adjacency list type, so that space complexity will be O of n plus c. So we can say that this entire thing is equivalent to O of n, a linear test space complexity. So this was space complexity. Now what about time complexity? Can anyone tell me the time complexity? Yeah. So basically time complexity will be big O of n plus e. Why n plus e? There are n nodes and e edges. So basically what we are doing here is that we are traversing through every nodes and see. So basically what happens here is that if there is any node, we are exploring all of its edges also. Okay. So but what will happen? We are not storing in the queue all the nodes. We will only store in the queue of those nodes which are not visited. But we are exploring them, right? So there is some kind of time requirement there. That is the reason we are taking big O of n plus e. I hope everyone understood it. So this is the time complexity and this is the space complexity of BFS algorithm, and they are both same as a DFS also. But the interesting part here is that BFS is an iterative algorithm and it doesn't require any recursive stack space. Instead, it takes its own stack space of queue data structure. Okay, and DFS is a recursive algorithm. And another advantage of DFS is that it's very concise, it's very precise, and very few lines of code are there too necessary to write so that we can traverse the entire graph. And BFS, the code gets lengthy sometimes. Okay, as you can see, there are multiple lines of code required for BFS. You have to create a hmm. But DFS code was just a small recursive code which can be easily typed out. Okay, so I hope everyone understood it. Hello Shankar, hello Yashwant, hello Vivek, hello Devesh. Are you all there with me? So we have almost reached to the end of our today's session, and in the next session, basically we will be doing a bit of practice of BFS and DFS problems. Okay, so let's look into it. What we have studied today, we have studied two important graph concept traversal techniques, DFS and BFS. We have seen that the DFS is a depth first search algorithm, which is a recursive algorithm, and BFS is a breadth first search, which is iterative. So in DFS, what we do, we keep on exploring the depth of any given node as long as it can be explored. And once we reach at the end, we backtrack to the starting node, and then we try to explore other possible nodes that there exist. Okay. And what we do in breadth, we breadth first search, we take a node, we try to explore all its neighboring nodes. Okay. And we store it in a queue. Again, we explore all the neighboring nodes of already stored nodes in the queue. So that basically we are doing a level wise traversal. Initially, we are at level number 0, then we are exploring all the nodes at level number 1, then at level number 2, then at level number 3, something like that. And we are printing in that fashion only. So both has its advantages and disadvantages, and we will look into tomorrow how to solve further questions. Okay, related to not tomorrow, day after tomorrow. Okay. Thank you, Shankar. Thank you, Yashwant. Yeah. So let me just give you a small reminder about this session. Yeah. So basically, we will be having this session every alternate day, and there will be around 15 to 16 sessions, and we will cover all the important concepts of graphs as well as trees. And at the same time, we will solve a bunch of problems, and we'll give you homework as well. And this is all done from preparing you all for interview point of view. Okay, I will be discussing all the famous interview questions as well, and giving you homeworks also, and discussing the relevant theory as well. So after this series, you can be very much confident about your preparation, at least from graphs and tree point of view. Okay, so good night, everyone. So if you have anything to ask, you can ask me. We have a few minutes left. Anything at all? Yeah, and I would request everyone to kindly join this session. Okay, so and also you can invite your friends as well. So this will kind of keep me motivated as well to create a better content for you all, and to discuss interesting and problems. Okay, so and if you all want a difficult session as well, you can just feel free to mention in the comments. Okay, and after the stream gets over, you can kindly do a bit of revision. And in the next session, I will be discussing a few important things. Let me tell you all right now. We will be discussing how to detect loops in a graph. We will also be doing a famous flood fill problem of, and after that, we will be doing a rotten oranges problem also. And we will discuss how to detect a connected component, count the number of connected components, detect cycle in both directed and undirected graph. And we will be doing all this stuff. Okay, so this is the point. Okay, so take care, bye bye, and let's see you day after tomorrow. Okay, a very good night to everyone. Thank you, Shankar. Thank you, Ashwant. Thank you, Devesh, and thank you, Vivek, for attending today's session. Okay, I hope that you all stay with me till the very end, and get everything, all your graphs and tree concepts very clear. Okay, bye bye.